Hi, my name is Irene Lee, and I will be presenting my Lab 1 on constant velocity. So here's just a little overview of the presentation. I will be starting with the purpose and then moving on to fundamental ideas and assumptions, and then models and the procedure, and finish off this presentation with a discussion. So in this lab, we aimed to observe the constant velocity motion of a real world object, which was the expo marker, by comparing the observed and predicted patterns as related to Newton's second law, which is also known as the momentum principle. For this lab, we used an observed model with the tracker application and also a predicted computational model with FlowScript. Um, and then after that, we compared these models to see how our observations related to the predicted computations. We ended up finding that even though the observed and predicted computations are similar, the two models separate in between time intervals and meet at a common end position. And here are just some fundamental ideas and formulas. We use Newton's second law, also known as the momentum principle, which shows that the change of an object's momentum depends on the mass and the force acting upon it. And then, secondly, we use Newton's first law, which shows that an object at rest remains at rest, and then an object in motion stays in motion unless acted on by an external force. We also use the position and velocity update formulas as well. So for the observed model, we use tracker um, to analyze the motion of the marker in a prior recorded video, and it allowed for us to plot points in time intervals of 0.033 seconds and the relative position of the expo marker for each of those time intervals. So for the predicted model, we used the GlowScript computation. And then for the initial conditions, the initial velocity is calculated using the tracker data, which is final position minus initial position over change in time. And for us, the initial velocity was calculated to be 0.264 in the x component. So just a continuation of the predicted model. Here's the rest of the code. Computing predicted constant velocity output from the surroundings, which could be the push force and potential friction, onto the system, which is the rolling expo marker. All right, so now comparing the observed and predicted. So seeing the predicted linear slope compared to the slight curve of the observed data graphed, we can conclude that the motion of the marker did not maintain a constant velocity. So just an experimental error could have been pushing the marker in as it went on a diagonal slope. And then lastly, to finish off my presentation is a discussion. So I could ask these two questions. My first question is, how would results change if the axes were interchanged? So I would say the results would stay the same, but the slope would actually flip since the signs of the values are changing. And then this will result in a downward line for the slope. And then my second question is it possible to say what push and pull forces are acting to give a net force of zero? There are many different factors and human contributions that change the possibilities of the net force. Therefore, it is hard to say what the push and pull forces are that are added to give a net force of 0.